Hey folks, Mr. Dell here. We are going to do a couple problems about percent decrease or increase. So we're going to talk about percent increase, decrease. I'm going to have two examples about that topic. I'm taking these problems from CPM, and this is from the parent guide, the from 7.1.7 increase or decrease parent guide is what this is from CPM's course 2. All right, so let's look at number 3 and then number 6. So we'll do these together and I'll go through that process of understanding percent increase or decrease. So it says the cars of early 1900s cost $500. Today, a new car costs an average of $27,000. What is the percent increase of the cost of an automobile? Now, when we think about percent increase, one of the standard ways of going about figuring out what that percent increase is to first let's talk about what is that increase or decrease. But in this case, we are dealing with increase. So if we start with $500 as the original cost, and then it from there grows in this case to $27,000. So that's the new. So what is that growth? What I need to know is I need to know what is the increase, right? So the increase in money we can determine by just using subtraction. So that increase is it added, right? Addition added how much? It added $22,000. So the increase is a $22,000 increase. Oh, I'm sorry. That's not 22,000. 26,500. So that is 5,000. So it started at 500 and went to 27,000. So it's 26,500 is the increase. So that's the dollar increase. So my question is, what is the percent increase, right? That's what I need to figure out. So what we're asking is what percent of this of the original is the increase, because I want to know what's the percent increase. So your standard is always this, is if you can find it's always the what percent of the original whatever, in this case original cost, equals that increase, or at sometimes it's a decrease. So that's how we determine a percent, is looking at this as an equation, right? So what percent of the original is equal to that increase or decrease? So what do we have here? So I'm going to write my equation. I'm going to write my statement. So I'm wanting to figure out what percent of 500, because that's the original, is equal to the increase, which is 26,500. So that's my start. That's my statement. And now I can write an equation, because whenever we're dealing with this unknown, in this case, what percent, I'm going to call that my x. So I have to have this value, this percent as a x times 500 is going to equal 26,500. So that's my equation. So that gives me a sense of what operation I need to do here. And I can see that the operation, in order to solve for x, if I had an equation like this, the multiplication to the variable would mean the inverse operation would be division. So this is where you solve and you now know, oh, okay, so what I've got to do is I've got to take and figure out what 26,000 divided by 500 is. 26,500 divided by 500, right? So that's our equation that we're going to, our mathematics that we have to do there to figure out what x is. So 26,500 divided by 500 equals 53. So x equals 53. All right, so let's go back. So what is x? X was the percent, right? But when we deal with percentages, when we're multiplying a percent times anything, we never deal with the raw percent. We always take whatever that percent is and we move the decimal place, right, a couple times over in order before we actually use the multiplication. So we'll actually move that decimal place. So if x equals 53, the multiplier would have been, um, 53, but with a few zeros there. So really, when you think about the other direction, if the multiplier in decimal form is 53, in percent form, we're going to take that decimal place and move it that way. Basically multiply by 100. When we're dealing with percentages, you always take the multiplier and multiply by 100, which moves that decimal place that way. So adds a couple zeros. So for my answer here is going to be 5,300% is that increase. Okay. So from 500 to 27,000 is a 5,300% increase. All right. So that's number 3 here. So that's that percent increase. So let's keep going here. Let me show you number 6. Let's do another one here. So number 6, now we've got a situation where we're starting off in 1906. This is always take my little notes. In 1906, that's the year, it was the Americans consumed an average of 26.85 gallons of milk. And then the years went along, and so 1998 now, the year 1998, it says that the average consumption was 8.32 gallons. So it wants to know now, what is that percent decrease? And if you look at my numbers here, right? So from 26 to 8, I'm decreasing. What is that decrease in gallons, right? If I look at my 26.85 minus 8.32, I'm going to get, let's see, what is that going to be? 18.53. That sounds about right? So if I subtract those two numbers, I get 18.53. So that 18.53 is my decrease. It decreased. It went from there and it decreased 18.53 gallons as far as the average consumption of milk, right? So, all right. So I go back to this right here, right? This is my standard way of finding this percent. I want to know what percent of the original is equal to, in this case, the decrease. So I'm going to ask what percent of the original, which is 26.85 gallons, is equal to or is the actual decrease, which is 18.53. Okay, so this is my equation. So I know my x is my percent. What percent? X times 26.85 equals 18.53. So again, that gives me a sense of then what operation I need to do, which is to solve for x, divide both sides by 26.585. And that's going to tell me what my percent as a multiplier is, right? The decimal form of my percent. So 18.53 divided by 26.85. And it looks like we've got, let's see, I'm going to round to the nearest hundredth. So that would be at the 9 there. So x is equal to 0.69. So that's my multiplier as a percent. But remember to take and now make that decimal into a percent. We always move that decimal place twice, or in other words, multiply by 100 because you want the percentage. So my final answer is going to be 69% decrease. All right, there we go.